In this lesson, we're going to talk about implicit differentiation. We got two types of functions. We have functions that are explicit, where we got y's on one side and x's on the other, like these three guys here. Then we got functions that are implicit functions, where we got x's and y's on one side, and we could have x's and y's on both sides. But the key is that we got x's and y's all together here. So, and we want to remember that when we're doing this, that y is a function of x, all right? So it's just not solved for x here, all right? So we want to treat y as a function like f of x, all right? And in order to do this, we'll need the chain rule, which we got in our pocket now, so that's good news. So let's look at some functions here. We got some functions on the left and the right. These ones are explicit, these ones are implicit, so we'll need the chain rule over here, all right? And so we're going to take the derivative of both sides on these guys, all right? So, righty. So to take the derivative here, we get y prime equals 1. So we're really taking d dx of both sides, okay? Taking the derivative of both sides, and we end up with y prime of 1. On the right side, when we take the derivative of this side, taking the derivative of this the left and right side, okay? Now the right side, when we take the derivative, we're going to need to use the chain rule. So derivative of y is y prime, really it's 1. We're going to take the derivative of the whole thing, use the power rule, drop the 1 down. 1 times y to the 0, which is 1y. And then we take the derivative of y itself, and we'll write that as y prime. Derivative of the x over here is going to be 1, and the derivative of 1 on the other side is 0. And now we can solve this for y, and just add 1 to both sides. Y prime equals 1. Solving it for y prime, that is. Okay, there we have it, and we end up with the same thing. All right, this one down here, we're going to rewrite as we're used to. Y equals x is negative 1. We want to use the power rule. So we take the derivative of this guy, so d dx of this side, d dx of this side, and we end up with the derivative of y is just y prime. And we got to drop the negative 1 here, x and negative 2. Maybe we'll write this as y prime equals negative 1 over x squared. Okay, old news, nothing new there. If we have this function, which is actually the same as that one there, we want to take the derivative here. We'll need some chain rule. So let's take the derivative d dx of this side, d dx of this side. Okay, so to do that, we take the derivative of the first, which is just x. The derivative of x is 1 times the second plus the first, which is x, times the derivative of the second. Derivative of the second here is y prime. And on the right side, we get 0. Okay, so now we sometimes we're just fine with this. We're going to leave it here. We took the derivative, but right now we'll need to solve this for y prime. So if we subtract y from both sides, we get this guy right here, and we get y prime equals negative y over x. Okay? And we're going to leave it just like that. This is an implicit derivative, so it's got y and x on both sides, but we've got it solved for y prime, and that's important. That's the key. A couple more. So we can take the derivative of this guy. We know that y prime is 2x. That's the explicit derivative there. This is the same function. Notice, solve this function on the right, and we'll get that same one on the left there. All right. So let's come over here, and we'll solve this guy. And so we could solve it for y, but we want to take the implicit derivative here. So to do this implicitly, we're going to take the derivative of both sides, d dx of both sides. You don't have to write that d dx. I'm just kind of showing you what we're going to be doing here. And so this is the quotient rule. So we take the derivative of the top, that's y prime, times the bottom, which is x squared, minus the top times the derivative of the bottom. The derivative of the bottom is 2x all over the bottom squared. So squared squared. On the right side, we're going to get the derivative of 1. And the derivative of 1, since it's a constant, is 0. All right? So this, we end up with the bottom, that's x to the 4th. Okay? Now, in this guy, since the right side became 0, if we multiply both sides by x to the 4th, this is just going to go away. All right, so x to the 4th on this side, that's going to cancel with that. Multiply by x to the 4th. Hey, 0 times x to the 4th is just 0. That's gone. And so our function becomes y prime x squared minus 2xy equals 0. Solving for y prime by adding 2xy to both sides, we get y prime equals 2xy all over x squared. And there's our implicit derivative. All right. So we can find derivatives explicitly or implicitly, all right? Yeah, so now here's our steps. Okay, our steps are to take the derivative of both sides, the equation, then evaluate using our derivative rules. And remember, use the chain rule. Don't forget the chain rule. All right. So every time you're taking the derivative of y, you're really doing the chain rule. All right. Anything involving y. So, and then last but not least, we want to solve for dy dx or y prime. All right. Because remember, y prime is the same as dy dx. All right. All right. So we're kind of using those interchangeably because they mean the same thing. Let's try a few here. D dx of both sides. Take the derivative of both sides. D dx of this side. Okay. And so this is just a circle, by the way. So we're finding the derivative of a circle. So let's take our derivative here. And so our derivative of x squared is just 2x. Our derivative of y squared now. Let's see here. Can we move this guy? So our derivative of y squared gives us, there we are. Okay, we gotta use the chain rule. So take the derivative of the whole, of the outside, that is, and the outside is 2y, times the derivative of the inside. What is the derivative of the inside? Well, the inside is y prime. And the derivative of the right side is just 0. Okay, so you see what happened there? That's where the magic happens there, all right? So we look at the whole here, drop to 2, and that's where our 2y came from. The derivative of the outside. And then the derivative of the inside, remember, y itself is a function. Since I don't know what the function is exactly, I can't do more than just say it's y prime. Okay, the derivative of y prime. So let's solve this for y prime. Subtract 2x from both sides, and then divide. We get y prime equals negative 2x over 2y. And, whoop, that's not a y. 2y. Okay. And we can simplify that, and we end up with y prime equals negative x over y. There's our implicit derivative. Okay. Excellent. So let's try some more. So we just found the derivative of this function implicitly. So we want to find the equation of the tangent line, all right? And so let's try that. Next step, we know the points here. It goes through 3, 4. That's the point we want to find the tangent at. So we're going to plug that in. Plugging in negative 3 or 3 and 4, we get negative 3/4. So that's the slope of our tangent line. So let's find our equation. So we're going to use our point slope form here, y minus, using the point we have. We plug in the y coordinate 4. So y minus y1 equals m, which the slope was negative 3/4 times x minus x1, which is 3. So point slope form. There's our equation. Now we can graph the point. If we look over here on the circle, we got the point 3, 4. There's our point 3, 4. And if we know the slope is negative 3/4, so we can go 3 down, 4 to the right. And we can go 3 up, 4 to the left. And now we'll draw our line in here. And we get a line about like that. So not too bad for a free-handed line. So that's the idea there, all right? Let's look down at this B here. And so we can find the tangent here of this line. Okay, we want to find the implicit derivative again. To do that, we're going to take the derivative of both sides. All right, so here we go. Let's go one term at a time. All right, derivative of y squared. Okay, y is a function of x, so we got to find the derivative by looking at the whole, dropping the 2 here. We have 2 y to the first. That's derivative of the outside. Derivative of the inside is y prime. Don't forget that. Easy to do. All right. Now let's take the derivative of the second term. That's just a function of x. So that's easy stuff. That's going to be 3x squared. Take the derivative of this, and we've got 2. Now let's take the derivative of both sides. Derivative of 1 is 0. Okay. And so we found our derivative. We did it implicitly, pretty quick and slick. Now we just got to solve it for y prime. So let's move all this stuff over to the other side. And then we're going to divide that by our 2y to get our final product, our final result. So we have our equation for our derivative, and now we just need to plug in the points 0, 1 down here to find the value of the derivative at that point, 0, 1. So plugging in 0 for x and 1 for y, we get 0 minus 2 all over 2, which is negative 1. All right, so we found the slope y prime equals negative 1. So last but not least, let's find the tangent line. And using our point slope form, y minus y1 equals m, which is negative 1, times x minus x1, which is 0. Little cleanup, this is just negative x, and let's add this 1 over to the other side and put in the slope-intercept form there. Okay? All right, we'll leave it at that. And we found our tangent line. So, all right, a couple more here, and we'll call it quits. All right, so now let's get some sine and cosine in the mix. All right, so and we're not going to mess with the tangent line right now. Let's just find the derivative of this implicitly. So, I'm going to have some quotient rule going on here. All right, so actually product rule. So, first thing we need to do is we need to find the derivative here implicitly. Okay, and so we end up with derivative of the first, which is 1, times the derivative times the second, plus the first of these two, which is x, times the derivative of the second. Now, careful. This second thing is a function of y, so we got to find the chain rule now, okay? The derivative of sine y is cosine y, and now, and we got to multiply that by the derivative of the inside, that's y prime, okay? So this is the derivative of sine y right there. Now let's go to the second term. So that plus is from our original there. So derivative of the first, well, the derivative of y here is y prime, all right? So we got y prime times the second, cosine x, plus the first, which is y, times the derivative of the second. Well, that's just plain old derivative of cosine of x. That's not hard. Negative cosine, negative sine of x. Okay, so we just got to watch out when it's a function of y. We got to use the chain rule when it's a function of y. Derivative of the right side here is going to be 0. And now it's just a matter of cleanup, all right? So we want to solve this for y prime. So what we're going to do is we're going to get all of this extra stuff and that doesn't have y prime, we're going to move it over to the right side, okay? And for the stuff that we do, it does have a y prime, we'll leave on the left. So I moved over those two terms underlined in red. These two terms here, I'll underline them in green. How about that? Okay. So these two terms we're going to factor out the y prime. And so when we factor out the y prime, we end up with something like this. So we got factored out the y prime out of these two underlined in green. And we've got this x cosine y left over. We've got this cosine x left over there, and the y prime out here. All right, so now we can solve it by y prime by dividing both sides. And there's our derivative in terms of x and y. All right, so that's our implicit derivative there. All right, so now, last little bit, we want to see how this can help us find second derivatives fairly easily. All right, so here we have a function where we want to find a second derivative implicitly. All right, so find d2y dx squared. So that's the second derivative, by the way. We haven't seen that a whole lot. So this is how we say find the second derivative is all that's going on there. All right. So let's do that. And we got a little typo. This should be an x there. So let's call this 2x cubed. All right. So let's find our derivative implicitly. Here we go. Derivative of the left. So we got 3x squared. All right. And so, I'm sorry, 2x cubed. How about that? Drop the cubed. We have 6x squared. Now find the derivative of this. It's a function of y here. All right, so we got to use a chain rule. So we do the derivative of the whole, just ignoring it, treating it like an x. Y to the first. All right. Now we got to take the derivative of the inside of this function here. The inside is just a y, so it's y prime. And on the right side, derivative of 8 is 0. Now we want to find the second derivative. All right, so let's find d dx of that again. Let's take the derivative of this whole jazz again. And so we get 12x. Now, here we go, a little bit chain rule going on here. Nope, product rule, and there will be chain going on. So product and chain going on. Derivative of the first here now. We better put this in some big parentheses. So derivative of the first is 6. Now we're going to use chain rule here. Okay, 6, that's the derivative of the outside. Derivative of the inside is y prime. Times the second. Okay, doing our product rule here. The first, which is 6y, times the derivative of the second. Well, the derivative of y prime is y double prime. Okay. Now, let's move this guy here. That's equals 0. Now all I got to do is clean it up and get that y prime by itself. Actually, we'll make that the y double prime by itself. So let's distribute. Maybe we'll call this y prime squared. Oh, that's going to be a minus. And now let's get the y double prime all by itself. So we get all that stuff over there. Let's divide by negative 6y. And we can finish it off with a little bit of cleanup. And there we have it. So we found our y double prime in terms of x and y and y. Oh, we're going to divide here. Dividing everything by 6 here. Actually, probably negative 6 would be good. Making this positive, this negative, and a y on the bottom. There we go. I think we got it. All right, so we found the second derivative. All right, so that's how we can find the implicit derivatives, and we can use those. They're very useful. They're easy to find. We don't have to waste time solving for y, all right? And we can use them for second and multiple derivatives as well. So there you have it. Go find some derivatives implicitly. Good luck.